Assalamualaikum. Okay, now we are going to continue discussion about topic 2, which is we have discussed about system concept. Okay, now we are going to discuss about a number system representation, information coding scheme, and also the logic gate and simple logic circuit. Before that, what is a data representation? Presentation of data, which is a manner so that a computer can process, we call as a data representation. Because the computer cannot process all the data, they have to represent using the form that the computer can understand. Okay, it represents off and on, which is 1 and 0. There are two ways to present the data in computer, which is one is a bit, or we call it as a binary digit, and another one is byte. Okay. If you look here, this is how and what the example to represent off and on. Okay, let's say this is the circuit of in a computer, which is represent the on or the off, which is state in the computer or the mobile device by the presence or absence of an electronic charge. So if you look here, they are on. Okay, on is 1. On is 1. On, and also the off. Alright. Okay, what is a bit? Bit is actually we call as a binary digit, the smallest unit of data the computer process, and it represents an electrical state on or off. Bit 1 is on and bit 0 represent off. Okay, next one. Byte. What's a byte? A byte is a group together as a unit. It's a bit, okay, which is 1 byte equals to 8 bits. It represents a character as a digit, a letter, a punctuation mark, or any symbol in a computer. So 1 byte equals to 8 bits. So that is the unit. Okay, the unit which is 1 byte equals to 8 bits. Alright, what is the difference between bit and byte? Okay, bit is the smallest unit of data which is the computer can process, and byte is 8 bits which is grouped together as a unit. So 1 bit equals to 8 bytes. Alright? Okay, that is the meaning of bit and byte. Alright, next we are discuss about number system. So what is a number system? A number system is a collection of symbol or digit which is collectively used to represent a numeric data. Right? And it is a set of values used to represent a quantity. Okay? So there are common number system that we will discuss, which is decimal, which is the number base is 10, binary, number base 2, and hexadecimal, number base 16. Alright? Okay. Okay, if you look here, this is the number system. A number system with the binary, octal, decimal, and hexadecimal. Let me explain one by one. For binary, which is a base is 2. We're using base 2. Okay, decimal, sorry. Okay, base also we call as the radix r. Okay, base also we call as radix. Okay, r we call as radix. Okay, radix, right? Or r, symbol r. Okay, what is a binary? Binary is actually where which is binary is 2, base 2, and then which is the symbol they use 0 and 1. The meaning of base 2 is they use 2 digit. They use 2 digit. 2 digits. Alright? Okay, for octal, base 8, they use 8 digits. Okay, 8 digits. 0, 1, 2, 3, 4, 5, 6, 7. So 8 digits. For decimal 8, decimal base 10, they use 10 digits. Okay, 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, for hexadecimal, which is 16 digit. 16 digit. Alright, so 16 digit, which is 0, 1 until 9. Okay, A, which is 10. 10. A is 10, B is 11, C is 12, D is 13, 14, and 15. So there are 16 digits. And normally for the decimal, which is base 10, is a very common because we use the decimal number for our daily life. For example, measure the distance, weight, count the money. Okay, so that is the most common digit. Okay, the number system for decimal, right? Okay. Okay, next. Okay, I hope you understand. For the decimal number system, okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, semua ya. Okay, so this is which is they consist of the number 0, 1, 0 to 9, the digit. Okay. Okay, for the decimal representation, 915 base 10, which is represent a quantity of 615. 615. So what you have to do is you can, if you represent 615 base 10, you can draw a table like this. Okay, and we use 0, 10, 0, 10. Okay, then for the 5 times 1. Okay, 10 raised to power 1. This is 10 raised to power 0, which is 5 times 1. Okay, this one is 1. 10 power raised to power 1, right? 10. And 10 raised to power 2, which is 6 times 100. 600. So 610, 5. Okay, so will be here, the total 615, right? Binary number system. Okay, for the binary number system, a method of representing numbers that has 2 as the base, and they use only 0 and 1. For example, 1012, 1010 base 2, 1100 base 2. Okay, so that is the binary number system. Okay, here is the table to represent the decimal. 1 until 11. So if you look here, this is the binary for 2. Okay, 2 power of raised to power 0, raised to power 1, raised to power 2, and raised to power 3. So let's say 1, for 1, which is, this is the answer, 0, 1, this one, okay, and 2, which is 2, 3, okay, this one is 2 plus 1, so it will be 3, okay, the answer. And 4, 1, because under 2 raised to power 2, right? So it would be 4, okay, and so on. So that is the meaning binary representation. Okay, for the hexadecimal, which is 0 to 9 and A to F, for example, like 3AE base 16. Okay, so this is example, base 16. Alright, if base 16 must be 16 raised to power 0, base 16, okay, 16 raised to power 1, 16 raised to power 2. Okay, for 1, okay, so this is 1, right? And for 2, here, which is this one, 0, 0, 1, 0. Okay, 0, 0. For the binary, if the binary convert to decimal, will be 3. Okay, 3. Right? Okay. Alright, so if you look here, binary to decimal conversion, in binary number, the column weight again from the right to left are as follow. So if you have a number 8421, which is a binary to decimal conversion, binary is which is 2, right? So 8421 here. Okay, 8421 in binary number column weight again from the right to left. Okay, so let's say this one, convert the binary 10110 base 2 to decimal number. Okay, so if you look here, you just write start with the 2 raised to 0, 2 raised to 1, 2, 3, and 4. So you just insert each number, each digit 10110 for each of the column here, and then you have to calculate. Okay, 1 times 0 is 0. Okay, alright, and then 2 times 1, because this one is 1, 2 times 1, 2. This one is 4 times 1, 4 times 1, 4. This one is 8 and 0. So your answer will be 0. And this one 16. You have to add all the numbers and you get the 22. Okay, so that is the decimal number. Okay, next, how to convert 18 to binary, decimal to binary. Okay, this is one is very simple. For example, okay, let's say 18. Okay, 18, which is how to calculate, which is you just divide. Okay, just divide like this. For example, I show you 24. Okay, 24, 2. Okay, you have to divide by 2. Okay, for example, for the binary will be 12, because 12 times 2 is 24. Okay, there will be 0. Okay, and for this one, 2. 2, of course, 6 times 2 will be 12. 0, and then another one 2. Okay, 2 will be 3. 3 times 2 is 0. Put your 0 here. 2. Okay, of course 1, 2, and it should be 2, right? Okay, you put the 1 here. Okay, right? And 2, 0. Bring the 1 here. Okay, so the answer will be 1, 1, 0, 0, 0. Okay, if you calculate 1, 1, 0, 0, 0, which is to decimal, alright, decimal 0, 0, 0, 1, 1. Okay, 2, which should be 0, 0, 0, 8, 16, right? Okay, so if you add the numbers, you will get the answer. 16 plus 8 is 24. So that is the answer. If you convert back to decimal, okay, you will get 24. Same goes to 18. 18, this is how you calculate. Alright? Okay. Next, ASCII code. Okay, this one is actually for the information coding scheme. ASCII code, EBC, DIC, and also Unicode. Okay, ASCII code is actually American Standard Code for Information Interchange. EBC, DIC is actually Extended Binary Coded Decimal Interchange Code, and also Unicode is Uniform Code capable of representing all the world language. So these are the different for ASCII code, EBC, DIC, and also Unicode. For ASCII code, which is first one, they use the 8 bits to represent characters. Represents 256 characters, okay, which is 2 raised to power 8, which is 256, and primarily used on PC and server. So this is ASCII code. We use ASCII code, for example. Okay, and next is a EBC DIC. Okay, 8 bits represent the characters. Okay, same, and they use on mainframe and server. Alright, they use only for mainframe and server. For this one, Unicode is actually they use for Windows, Mac, Linux. Okay, they use 16 bits to represent a characters, so that they capable to represent 65,536 characters. So that are the different. Okay, so do you understand? Alright. Okay, so next is we will discuss after this about the logic gate and simple logic circuit. Okay, so that's all for now. Thank you.